One of my favorite microcontroller devices out there right now is the Circuit Playground Express, or CPX. I love this thing, and one of the things that's great about it is that it's packed full of sensors. You can detect acceleration, sound, light, all kinds of stuff with this simple device. Now today, we're going to do something kind of complicated, but totally worth it, and that's figure out how to save data from this device onto the device. So one of the cool things about the CPX is it's so small and light. It's a great for portable devices or even wearables. And so I want to be able to put a little battery pack on here and put this on my robot or even put this on my hat. And maybe I want to collect some of the data that's coming off the device. We're going to learn how to do that today. It takes a little bit of tweaking, but follow with me. I don't think it's going to be too bad. So let's go ahead and get started. The first thing we're going to do is we're going to write a small file to this called boot.py. Now, when I hit restart, boot.py is going to be read, and actually the trick I'm going to use today is to use the switch on board the CPX to do a little bit of work for me when I boot. So let's go ahead and get started. So I'm going to go ahead and open up my Mu programming environment, my Mu IDE. Still a great, clean, awesome way to program my CPX. Let's just make a new file. And here's what I'm going to do. I'm going to import a module called storage, and we're going to see what we're going to do that with a second. And we're going to do the normal thing, and that's from Adafruit circuit playground .express import CPX. So that's obvious. That's all the modules and stuff that come along with the CPX. And we're just going to do one thing, and we're going to say storage remount the root of the drive, and I'm actually going to use whatever's going on at the switch in that function. So I'm going to say cpx.switch. And so what that's going to do is on boot. So I'm going to save this as boot.py. So I'm going to hit save. I'm going to save it onto my circuit Pi. I'm going to save it as boot.py. Okay. So when the device remounts, or when it gets, it basically boots up and gets mounted on your computer, it's going to look at the switch, and if the switch is true, it's going to enable me to save data to the device. And so what I'm actually going to put in here is a little comment to myself to remind myself of that left you can write, and right is for collecting data. So if the switch is to the right, that will enable my code that I'm about to write to save data to the device. If the switch is to the left, that's for when I'm writing code and I want to be able to save data through my file system. So that's boot.py. You don't have to totally understand what's going on there, but that's going to enable us to, when the switch is to the left, to write code like we've always been doing. But when the switch is to the right, I can have code running on my CPX that is saving data to the CPX's file system. So that's boot.py. I'm going to go ahead and hit save. Now I'm going to make a new file, and now I'm going to actually collect some data. So the normal thing I'm going to do is I need to import my CPX stuff. I'm also going to import time. We'll do that. We'll see. Because we're going to have something run in a loop, and we don't want to run too fast. So our normal thing is we're going to use time for a sleep, maybe a quarter of a second or half a second or something like that. So first thing I'm going to do is I'm going to turn my CPX, the red LED on, and that is the tiny LED that's on the corner of the device. I'm going to go ahead and turn that on. That's CPX.red LED equals true. All right, now I'm going to enter my while loop, but we're going to use a new thing to get today. Again, I warned you, there's going to be a few things new coming at you today. One of the new things we're going to do is we're going to do a try except functionality or syntax in Python, which is actually a really powerful thing in Python. And there's other programming languages where you can ask your code to try something, and if it fails to do that, then execute some different code. So this is a pretty handy thing to do in programming, and especially right here. So here's what we're going to do. We're going to say try something, and then the syntax is accept. So we're going to try something, we're going to try to do something, in this case, we're going to try to write to the file system, and if it fails, we're going to do something with that exception. So what I'm actually going to say is I'm going to open a file. So that's what I'm going to ask Python or my CPX to do. I'm going to open a file. I'm going to name it, let's see, temp data.txt. I'm going to try to open a text file, and I'm going to try to open it using the append functionality. So if this file already exists, I'm just going to append to it, and I'm going to open that as my file. So then once I do that, then I'm going to enter in my while loop, my while true loop. So that's going to enter into an indefinite loop. This is going to happen over and over and over. I'm going to collect some data. I'm going to collect some temperature data. So that's CPX.temperature. And so I'm going to assign whatever the temperature reading is. I'm going to assign that to a variable called temp, and I'm going to write that to a file. So I'm going to say my file, which I just created, my file.write temp. Now I don't think that will work as I've written it right there, because temp I think comes across as an integer, and I think the write function wants a string. So if we haven't talked about strings yet, strings are just text. It's a file data type as opposed to an integer or some other data type. I think I have to turn that into a string if I remember right. So I'm going to get the temperature value. I'm going to turn it into a string and write that string to the file, and that's it. The next thing I have to do in order to get that to actually save to the actual file system, I have to say flush. That tells the CPX to actually take whatever's in the file memory and actually write it out to the file. And then here's what I'm going to do. I'm going to say CPX.readLED equals not CPX.readLED. And so what that just means is if it's on, which it is at this point, turn it off. And next time this while loop runs, turn it off, and then turn it back on. And then I'm going to say sleep, or I guess I imported time, so time.sleep. I'm going to delay 1 second. I'm going to write myself a note. 1 second delay means it's working. So if the try function succeeds, in other words, it is able to open the file, it's able to append to it, I'm going to see a once per second light blink. That's what's going to be happening on my CPX. So that while true loop is going to be happening once per second, and once per second it's going to flip the light from off to on, and every time that once per second happens, I'm going to collect the temperature data, assign it to temp, I'm going to turn that into a string, write it to the file, and then flush just actually cause it to go into the file system. So that's what's going to be happening once per second. So if that fails to happen, and I'll show you in a second why I'm writing it this way. If that fails to happen, I'm going to enter a different while loop. So while true, let's see, I think I need to catch that. I might not even need to catch that exception. Let's just try it this way. CPX dot red LED equals not CPX. Type dot red LED. And then I'm going to say time dot sleep 0.1 seconds. So here's why I'm writing it this way. If something goes wrong, I want it to blink fast. That's my indication that I've done something wrong. So if it's blinking once per second, that means it's actually saving data. If it's blinking really fast, that means I've screwed something up. Let's go ahead and give that a shot. I'm going to hit save, and I'm going to name that as code.py. So let's take a look at my CPX. It is flashing really fast right now. That means there's an error. Now, in my boot program, I made myself a note. Oops. I made myself a note in my boot program that left means you can write, and right is for collecting data. I have it to the left, which is great because I was just adding code. So I was just modifying my code. I need it moved to the left so I can save data from my laptop to the device. Now that I'm ready to collect data, I'm going to switch to the right and hit the reset button. Now that I've hit the reset button, it's going to fire off that boot.py file. And if everything goes according to plan, it is now blinking slowly. It's now blinking slowly. My file browser opened up because I just mounted a new drive. That's what happens when you hit reset. When you hit reset, it remounts, and fortunately, that's what we're taking advantage of. Because it remounts, we're firing off the storage.remount function. And notice it's it's blinking slowly, which means I'm collecting data. That's awesome. So we're actually just about done. I've written a boot.py file, which is I'm able to check the position of the switch and then decide whether I'm writing code or the CPX is writing data for the device. And then I've written a little bit of code here to actually collect temperature data once per second. And now I can see that that's working. Okay, now that it's collected a little bit of data, I've let it run for a minute or so. I'm gonna look, and on my CPX, I should have a file now named tempdata.txt. So let's take a look. Tempdata.txt, there it is. And you can see that it's just a long string of temperature numbers. So it's about 31 degrees, 31.000 something, and then it's 31 degrees again. So what I've done is I've collected tempdata.txt and appended it. I've collected temperature and I've appended it to tempdata.txt once per second. Now that makes it kind of difficult for me to actually parse through my data. So before we finish up today, I just want to add two quick additions to the file we have right there, and then we'll be done. First thing I'm going to do is I'm going to collect my data on once per line, or one data point per line. And the way to do that is I'm going to add /n, and that's my new line character. Let's see. I think what I'll do here is I'll say temperature is cpx.temp, and then I'm going to make a new string, call it my string, and that is the string value of temp plus the new line character. So right there, if I say \n, that's going to tell most text editors or things like that to interpret that as a new line. So I'm going to take the temperature, I'm going to turn it into a string, and then I'm going to append the new line character at the end of that string, and that's going to be what I write to my file. I'm going to write my string to the file. So it's a little bit more complex to have to create a string and append to it, but that's just going to make it a little cleaner when I open up that file. The next thing I'm going to do is every time I collect data, I'm going to rewrite over tempdata.txt. And maybe I don't want that. Maybe I want to run this thing a few times and collect new data every single time. There's a few techniques for doing that. What I usually do is if I'm running a full version of Python where I have access to the timestamp, I'll call the file like temperature data, and then I'll throw in a timestamp. So it's like whatever today's date is and the time and the seconds. So that'll always be unique, and so it'll always be a unique file name. With CircuitPython, I don't have access to the real-time clock, but a decent workaround is to create a file name, and I'll call it call it file name. And let's see, for this, I'm just going to say temp data plus, I'm going to import random. I'm going to add just a random number. So I'm going to say random.random. That'll give me a number between, that'll give me a random number between 0 and 1. I'm going to make that a big number plus, or yeah, times like 10,000 or something like that. What is that? That's 100,000. So I'm going to take some random number between 0 and 1, multiply by 100,000. So that'll give me a number between 0 and 100,000. I'm going to want to make sure that's an integer, so make sure it's not a decimal. So I'm going to int it, turn it into an integer. Then I'm going to turn that into a string. Now there might be cleaner ways to do this, but that's what I'm going to do. And then I'm going to add the dot text. So my file name, instead of being temp data.txt every time, is going to be temp data, then some crazy number, and then dot text. A little bit complicated, but that ensures almost definitely there's about a 1 in 100,000 chance that I'll overwrite my file this time. So I'm going to have my temp data will be some string. It'll be my file name will be temp data, then some long number, then dot text. And so hopefully that'll be unique every time. So I'm going to hit save on that. Now my switch is to the left, so I was able to save that. Now all I have to do is throw that back to the right. So you can see that it's blinking quickly because when I hit save, code.py is running and it's not able to write to the file, so it's doing the fast blink thing. I'm going to switch it to the right and then hit reset. And let's see what happens. It should be blinking slowly. Let's see if there it goes. Once per second. Once per second, it's blinking slowly. Oh, and I'm going to have to reset that. I never changed the file name. So I just threw it to the left. So this is how you edit when you're doing this kind of thing. I just threw the switch back to left, hit boot. So now I can open file name instead of tempdata.txt. Hit save. There. Throw the switch to the right. It's blinking fast right now because I just hit save. Now I just threw the switch to the right. And now I'm going to hit boot again. Hopefully it'll be blinking quickly. And we've got a unique file name with temperature data once per line. There it is. You can see the file now. It's called temp data 32485. And let's see if I open this in Notepad. Notepad lately has been ignoring my new line commands. Let's try that. Let's throw it to the left. Hit reset. And let's see what kind of data I have. I actually been opening it in my browser to get a good, well-formatted text. There it is. So looks like the new line character is ignored in Notepad. But if I open it in my browser, so if I open up my browser, open that file, there should be all my data and new line per file per data point. That's great. So I've used this to collect temperature, to collect acceleration. I was firing off rockets and I threw a CPX onto a rocket and then collected a bunch of acceleration data. Then I was able to plot it. Lots of cool uses of saving data to the system. Takes a little bit of tweaking. You need to create that boot.py file, and you need to get good at learning how to write to files in Python, but I think, as we can see, not too tricky. So go ahead and have some more fun with your CPX. Until next time.